revision, let's move forward and understand the various salts of the oxoacids. So let's understand about the salts of the oxoacids. Definition: oxoacids are those in which acidic proton on a hydroxyl group with an oxo group attached to the same atom. So in this type of acids, the proton which is responsible for the acidic character of the substance is not directly bonded to the central atom. So this is the central atom carbon in H2CO3. You can see that this hydrogen which gives the acidic character to the carbonic acid is not directly bonded to the carbon, but it is bonded to the carbon via oxygen. The same thing you can see into the sulfuric acid. You can see this, both the hydrogen are not directly bonded to the sulfur, but they are bonded to the sulfur via oxygen. So they are bonded in the form of OH here in both the cases. These type of substances are known as the oxoacids. Even if you look into the HNO3, you have N double bond O. This is NO2, and then you have O, and then you have H. So this H is not even directly bonded to the nitrogen, which is responsible for the acidic character in case of the HNO3. So this HNO3 is also an oxoacid, we can say. So now you might have understood about the oxoacids. Alkali metal forms salts with all oxoacids. So these all oxoacids, with all the oxoacids, alkali metal makes salts. They are generally soluble in water. So the salts of alkali metal with oxoacid are generally water soluble, and they are thermally stable. They are stable also. At room temperature you can find them. Carbonates and hydrogen carbonates of alkali metals are also highly stable to the heat. Either for alkali metal we can write M2CO3 like Na2CO3 or K2CO3, and MHCO3 like NaHCO3 or KHCO3. Now there is one special thing, Li2CO3, which is a lithium carbonate, not thermally stable. LiHCO3 doesn't exist as a solid. Li2CO3 is not thermally stable, and LiHCO3 doesn't exist as a solid. So these are the exception, or this is the exception that you should know. As the electropositivity increases down the group, stability of carbonate and hydrogen carbonate increases down the group. So as the atomic number increases, if you go down the group, the stability of carbonate and hydrogen carbonate increases. Lithium carbonate is not thermally stable and decomposes on heating. Because lithium, being very small in size, polarizes a large carbonate ion, leading to the formation of more stable Li2O and CO2. You can see that lithium carbonate, just providing a very small amount of it, it turns into Li2O and CO2. LiHCO3 does not exist as a solid, so it is never found into the solid state. LiHCO3, lithium hydrogen carbonate, is not found into the solid state. Now, my dear students, we want to study about the anomalous properties of lithium. So let us understand the various anomalous properties of lithium, my dear students. Anomalous behavior of lithium is due to the number one, exceptionally small size of its atom and ion. So the size of lithium is very small, and not only atomic size but ionic size is even very small. Lithium being small in size, it is highly polarizing, so it has got very high polarizing power. That means it has got charge is to radius ratio very high, and that is what it makes its highly polarizing or give its highly polarizing power. As a result, there is increased covalent character of lithium compounds due to polarizing power, or as lithium can polarize the other negative ion. Suppose this is your negative ion. Lithium can, being very small, lithium can polarize these ions, create a distortion, and that is what it generates the covalent character. So lithium shows some of the other way the sharing character of electron, but does not they exist like actually they exist as a cation and anion, but due to the distortion of the anion, which is bigger in size, due to the very small, very big charge is to size ratio of lithium, there is distortion takes place, and due to distortion, there is a uh, there is covalent character increased into the lithium ions or lithium compounds. So that is why as these lithium compounds are generally covalent in nature, being covalent they are, as a result there is an increased covalent character in lithium compound which is responsible for their solubility in organic solvents. So these lithium compounds are soluble in organic solvents. Now, suppose you are asked in the exam why lithium compounds are soluble in organic solvent. You can write the above answer that lithium compounds or lithium has got exceptionally small size. Lithium has high polarizing power. Lithium has very high charges to radius ratio, and that is what it causes the covalent character, and that is why they are soluble, or the lithium compounds are soluble into the organic solvents. Further, lithium shows diagonal relationship to the magnesium. So lithium is very similar to magnesium. Now first let us see the points of difference between the lithium and other alkali metals. This is the very important point of your this chapter. Please try to learn it well. Lithium is much harder, and its melting and boiling points are higher than other alkali metals. The first point, that lithium is harder than the other elements of the alkali metals, and it has got very high or comparatively high boiling and melting point. Lithium is least reactive among the alkali metals, but strongest reducing agent among all the alkali metals. So lithium has got little higher ionization enthalpy, and that is why it does not easily form the +1 ion. That is why it is comparatively less reactive as a metal. But my dear students, it has got very great or highest reducing property due to its most negative electrode potential value. On combustion in air, lithium mostly form oxide, mainly, or lithium mostly form oxide or mainly form oxide, mainly Li2O, and small amount of peroxide Li2O2, while the other alkali metals mainly form their peroxide or superoxide, especially K, Rb and Cs. They majorly form superoxide because they are bigger in size. Next, LiCl is deliquescent. Deliquescent means it contains the water of crystallization and crystallizes as a hydrate LiCl into 2SO, whereas other alkali metal chlorides do not form hydrates. So you won't find NaCl into something H2O. No, NaCl you will find anhydrous. Lithium hydrogen carbonate LiHCO3 is not formed in the solid form, while all the other alkali metals form solid hydrogen carbonate. Please remember that, or we have just discussed that lithium hydrogen carbonate is not stable and it could not be found into the solid state. But we know that sodium hydrogen carbonate and all the other elements of group 1, they can form the solid hydrogen carbonate very easily, and they are stable, even they are thermally stable, and they are found into the solid state. Lithium, unlike other alkali metals, forms no ethyl ion. That means lithium does not react with the ethyne to produce ethynite, while the other alkali metals form ethynite when it reacts with the ethyne. Suppose sodium, if it reacts with the ethyne, C2H2, it will form NaC2H2. This kind of sodium ethynite is formed, which lithium cannot form it. Lithium nitrate on heating gives NO2 and O2, whereas the other nitrates on heating, they gives the nitrite and O2. You can see that lithium LiNO3 gives 4 LiO plus 4 NO2 plus O2, but NaNO3 will give NaNO2 and O2. So lithium nitrate gives lithium oxide, but sodium nitrate will give sodium nitrite and oxygen. Nitrogen dioxide is not produced in the case of the other alkali metal, nitrates. Sorry, dear students. Let's move forward. Lithium chloride and lithium oxides are comparatively much soluble in water than other alkali metal fluorides and oxides or other compounds. So lithium fluorides and lithium oxides are comparatively much soluble. They are little more soluble in water as compared to the are much soluble in water than other alkali metal fluorides and oxides. Now, what is the reason that these other metal fluorides and oxides are generally having very high lattice enthalpy, and that is why they are comparatively less soluble. Points of similarity between lithium and magnesium. Now, let us understand the points of similarity between the lithium and magnesium, my dear students. The similarities are as follows. Both lithium and magnesium have similar atomic as well as ionic radii. You can see that the atomic radii of lithium is 152 picometer, whereas for magnesium it is 160 picometer. And ionic radii of lithium is 76 picometer, and for magnesium it is 72 picometer. Both lithium and magnesium are harder and lighter as compared to the other elements in their respective group. So compared to the other elements of the group, lithium and magnesium are harder. So they are harder, but they are lighter. So that means their density is less, but they are very tough and they cannot be easily broken. Whereas the other elements, for example, group 1 elements, they can be easily cut with the knife. Both lithium and magnesium react slowly with water, not violently or not vigorously, whereas the other elements react vigorously and violently. You are well aware that sodium reacts violently with water, and calcium comparative to magnesium reacts violently with water, or it can be easily react. This calcium can easily react with water. Oxides and hydroxides of lithium and magnesium are much less soluble in water. So oxides and hydroxides of lithium are much less soluble in water. Hydroxides of magnesium and lithium decompose on heating. So hydroxides of magnesium and lithium decomposes on heating. So if you heat the lithium hydroxide, it will give the lithium oxide and water. If you heat the magnesium hydroxide, it gives the magnesium oxide and water. Let us study a few more similarity between lithium and magnesium. Let's move forward. Both lithium and magnesium forms nitrides Li3 and Mg3N2 by direct combination with nitrogen. So lithium and magnesium directly combine with the nitrogen and forms lithium nitride and magnesium nitride. The oxides of lithium, that is Li2O, and magnesium MgO, do not combine with excess oxygen to give any superoxides. So lithium and magnesium do not form any superoxides. The carbonates of lithium and magnesium decompose easily on heating to give oxides and CO. Please remember that lithium carbonate and magnesium carbonate on heating gives the lithium oxide and carbon dioxide, whereas the other element of group 1 actually they do not form it. So they, instead of nitrate, from nitrate they give nitride. Solid hydrogen carbonate is not formed for both lithium and magnesium. So LiHCO3 or MgHCO3, both are not produced in the solid form. Please remember. Both lithium chloride and magnesium chloride are soluble in ethanol because they have the covalent character. So both lithium and magnesium chloride have the covalent character, and that is why they are soluble in ethanol. Both lithium chloride and magnesium chloride are deliquescent. That means they absorb the water and they have the water of crystallization. So they crystallize from the aqueous solution as their hydrates. You can see that LiCl into 2H2O, whereas MgCl2 into 8H2O. So these were the similarities between the lithium and magnesium. And now, my dear students, we want to study about, or here we finish or complete our study about the group 1 elements, and now we are going to study about the group 2 elements, which are known as the alkaline earth metals. So dear students, if you have any doubt, you can ask me. Dear students, if you have any doubt in all this, you can ask me. Okay, then let us start studying about the group 2. Group 2 comprises beryllium Be, magnesium Mg, calcium Ca, strontium Sr, barium Ba, and radium Ra. They follow alkali metals in the periodic table, so that is why they are group 2. These means except beryllium are all known as alkaline earth metals. So beryllium is not known as an alkaline earth metal. Why? Because oxides and hydroxides of beryllium are not alkaline, but they are amphoteric in nature, and that is why beryllium is not considered as an alkaline earth metal. Let us study about the electronic configuration. The general electronic configuration of this element is a noble gas NS2, and that is why they form the second group. So we can study them, we can study or look into the electronic configuration. You can see beryllium is helium 2s2, magnesium neon 3s2, calcium argon 4s2, strontium krypton 5s2, barium xenon 6s2, and radium uh, radon 7s2. So general electronic configuration is noble gas NS2. Now we should study about the atomic and ionic radii, my dear students. The atomic and ionic radii of the alkaline earth metals are smaller than those of the corresponding alkali metals in the same period. So there we know that going left to right in the periodic table, the atomic radii decreases, and that is why the atomic radii of a group 2 element is smaller than the atomic radii of the group 1 element. This is due to the increased nuclear charge in these elements within the group. So that is what it happens because of the increase in nuclear charge. As the atomic number increases, nuclear charge increases because the number of proton inside the nucleus also increases. The atomic and ionic radii increases with increase in atomic number. That means if you go down the group, the atomic number increases, and that is why the atomic and ionic radii of group 2 element also increases because of the addition of the extra shell into their atom. Now, ionization enthalpy. If you look at their name, they are alkaline earth metals. So they are metals, and that is why they should possess the lower value of ionization enthalpy. But if you compare their ionization enthalpy with group 1 elements, what happens? These group 1 elements are generally group 1 elements have generally the lowest ionization enthalpy, but as you move from left to right, the nuclear charge increases, and that is why the ionization enthalpy of group 2 elements is second lowest, or even more than the ionization enthalpy of group 1 element. The alkaline earth metals have lower ionization enthalpy due to fairly large size of the atom. Since the atomic size of the atom of element increases down the group, their ionization enthalpy decreases down the group. So as the size increases, ionization enthalpy decreases because the electron is placed away from the nucleus. The first ionization enthalpy of the alkaline earth metals are higher than that of the first ionization enthalpy of alkali metals. So that is what I said, that the first removal of first electron is very easy for alkali metals as compared to the alkaline earth metal. Higher first ionization enthalpy is due to why the first ionization enthalpy of alkali metal is lower than the alkaline earth metal. The reason is completely filled s orbital. In s orbital they have 2 electrons, so s orbital is completely filled, and that is why the removal of one electron from ns2 is difficult. So it is difficult to remove the electron. Second, smaller size of the alkaline earth metal as compared to the alkali metal in corresponding period, and that is why it is easy. It is not easy to remove the electron from the remove the first electron from the alkaline earth metal as compared to the alkali metal. But when it comes to the second ionization enthalpy, that means removing the, see, if you have m, you will get m plus 1 electron, and that is what you call it IE1. So the energy required at that time is IE1, but now you have m plus 1 and you get m plus 2, and one electron is being removed. At that time the ionization energy is known as IE2. So when it comes to this, my dear students, we can easily understand that it is difficult to remove the second electron from the alkali metal, but this alkaline earth metal can easily allow the second electron to be removed. Let us see what is the reason. Second ionization enthalpy of alkaline earth metal is smaller than the second ionization enthalpy of alkali metal in the corresponding period. What is the reason? This is due to the, after removal of one electron, alkali metals have stable electronic configuration like inert gases. So if you have NS1 and then you have noble gas NS1, and if you remove one electron, it becomes like noble gas. So when one electron is removed from the alkali metals, this is the condition that they have the noble gas like electronic configuration. But for the alkaline earth metals, the electronic configuration is like a noble gas NS1. So if you think about the alkaline earth metal, they have the general electronic configuration NS2 and noble gas, and that is why when one electron is removed, what happens? They have the electronic configuration like noble gas and NS1. So still one electron is available in the shell. They do not have exactly like the noble gas electronic configuration, and that is why it is easy to remove the electron from the M plus 1 ion of the alkaline earth metal. So general electronic configuration for alkali metal is noble gas NS1 for group 1. For alkaline earth metal it is noble gas NS2 for group 2. So group 1, after removal of one electron, the electronic configuration is noble gas NS0, but after removal of one electron, for group 2, after removal of one electron, the electronic configuration is noble gas NS1. So it is easy to remove second electron from noble gas NS1 as compared to the stable noble gas NS0, and thus electron from noble gas NS1, electron from noble gas NS0 require high energy to be released. The second ionization enthalpy of group 1 element is higher than the second ionization enthalpy of group 2 elements, and that is how you can easily understand that group 2 elements have lower second ionization enthalpy, but they have higher first ionization enthalpy compared to the group 1 elements. This is even a tricky question, so it may be asked. Then, my dear students, we should study about the hydration enthalpy. So let us study about the hydration enthalpy. Like alkali metal ions, the hydration enthalpy of alkaline earth metal ion decreases with increase in the ionic sizes. So down the group, so as we go down the group, the the hydrogen enthalpy decreases. We know the order of hydrogen enthalpy: beryllium plus 2 is more than magnesium plus 2, magnesium plus 2 is more than calcium plus 2, calcium plus 2 is more than strontium plus 2, and strontium plus 2 is more than Ba plus 2. This hydrogen enthalpy depends upon the charge is to size ratio. Going down the group, the size increases, and that is why the charge into size ratio overall, this charge into size ratio decreases, and that is why the hydrogen enthalpy decreases. Let us study it. The hydrogen enthalpy of alkaline earth metal ions are larger than those of the alkali metals. Thus, compounds of alkaline earth metals are more extensively hydrated than those of the alkali metals. Now, my dear students, if we let us even understand about the size of the alkali metals and alkaline earth metals. So, if we go left to right, we know that the size decreases, and that is why the size of the alkaline earth metal is smaller than the size of the alkali metal. So here, if the size decreases, when we go from alkali metal to alkaline earth metal, the size decreases. So due to the smaller size, this charge is to size ratio is comparatively higher, and due to the higher charge into size ratio, charge is to size ratio, the hydrogen enthalpy of group 2 element is more than the hydrogen enthalpy of group 1 element, and that is why these compounds of group 2 elements are more hydrated, and that is why they may possess the more number of water molecules as a water of crystallization. So you can see that MgCl2 into, you can have MgCl2 into 6H2O, CaCl2 into 6H2O. These kind of salts are possible with the alkaline earth metal, and they are more hydrated. The higher hydrogen enthalpies are due to the large charge is to radius ratio or charge is to size ratio. Common oxidation state of group 2 element is +2. So for group 1 it is +1. For group 1 the common oxidation state is +1. For group 2 common oxidation state is +2. And going left to right, the size decreases. So my dear students, in going left to right, charge increases but size decreases, and that is why the charge density, we can say, or charge is to size ratio, and that is why the charge density, which is charge divided by volume, increases, and as the due to the increasing charge and decreasing volume, the charge density of group 2 element in a given period is quite larger than group 1 element, and thus KCl and NaCl are not hydrated, but MgCl2 and CaCl2 exist as a hydrated salts like MgCl2 into 6H2O and CaCl2 into 6H2O. Now let us study about the physical properties of alkaline earth metals. So the alkaline earth metals are silvery white, lustrous, and relatively soft but harder than alkali metals. So as compared to the other metals like metals of group, metals of D block, metals of F block, metals of P block, these metals are soft, but they are harder than the group 1 metals called alkali metals. Beryllium and magnesium appear to be somewhat grayish. So beryllium and magnesium have grayish color. They are not silvery white, or they are not as silvery white as the other elements. Melting and boiling points of these metals are higher than the corresponding alkali metals. Due to the smaller size, the trend is, however, not systematic. So you can see some variations, but overall we can say that the melting and boiling points are comparatively higher as compared to the alkali metals, my dear students. Due to the low ionization enthalpies, elements of group 2 are strongly electropositive. So they are electropositive as compared to the other metals of group number, other metals of block T, block D, F. Electropositive character increases down the group. So if you go down the group, the electropositivity increases because the last fill electron is filled away from the nucleus, and that is what it is easy to be removed, and that is why going down the group, the electropositive character increases or metallic character increases, we can say. Calcium, strontium and barium impart characteristics brick red, crimson and apple green color. So the electron present at the lower energy level goes to the higher energy level, and while coming back it radiates the energy in the form of light. This light falls into a particular visible region, and that is why, my dear students, we can see that various colors for this flame of the various element. For example, calcium impart the brick red color, strontium impart the crimson red color, and barium impart the apple green color. Please remember, this is the very important point, and it may be asked into your exams or even in your competitives. So once again, I would like to repeat that the element of group 2, they even impart the various colors. For example, calcium imparts brick red color, strontium imparts crimson color, whereas barium imparts apple green color. The electron of beryllium and magnesium are too strongly bonded to the nucleus. Please remember that the electron of beryllium and magnesium are too strongly bound to the nucleus that with the energy of the flame, they do not get excited to impart the color. We have seen that beryllium and magnesium are little harder, and that is what it is because of the strong metallic bond between the beryllium metal kernels, and that is what, or magnesium atoms, and that is what it makes them. Even the electrons are bonded strongly to them, and just by the energy of the flame, they do not get excited, and that is why they do not impart color characteristics. That is what we can understand. Let's move forward and study more. Beryllium and magnesium do not give, or beryllium and magnesium do not give or impart characteristic colored flame, and that is why they cannot be detected by the flame photometry. The flame photometry is the method that can be utilized for detection of the calcium barium plus 2 and Ba plus 2 ions in the given salt. So by heating the salt on the flame, we can identify whether Ba plus 2, Ca plus 2 or Sr plus 2 ions are present in the salt or not. Alkaline earth metals are very good conductors of heat and electricity. So alkaline earth metals are very good conductor of heat and electricity. Electrical and thermal conductivity of alkaline earth metal is higher than those of alkali metals. Now please remember that this electrical conductivity depends upon the free electron. Now if you look into the electronic configuration, they have NS2, whereas the alkali metal has got NS1, and that is why the number of electrons, or if we explain them with the C model, they have more number of electrons, and that is why the electrical conductivity of this group 2 element is higher or more than the electrical conductivity of group 1 metals. Now my dear students, we want to study about the chemical properties of these alkaline earth metals. But I think time does not permit us, and we should not move forward. We will study the chemical properties of these elements into the next period. Now if you have any doubt, you can ask me. Dear students, if you have any doubt, you can ask me.
Sir.
Okay, then let's move forward for the revision, my dear students. Let's do the required revision. Should we go for revision? कुछ नहीं पूछना तो revision करते हैं.